Hi, good morning. So today we are dealing with the chapter amines and some of its preparation methods. So first of all, let's see what are amines. We know ammonia, is it not? Ammonia is NH3. It has a nitrogen and 3 hydrogens. So amines are organic compounds that are derivatives of ammonia. Derivatives means what? We replace these hydrogens with some alkyl or aryl groups. Okay, so if this is ammonia, suppose this is ammonia, this is not the basic structure. Actually we know ammonia is pyramidal structure. So just see, if this is the ammonia, then we replace this hydrogen with an R group or an aryl group. Aryl group means that has benzene ring, C6H5 group. Okay, so if you replace these hydrogens with R group or aryl group, then it becomes what? Derivatives of ammonia, that is amines. Okay, if you replace one single hydrogen with R group or aryl group, then we get primary amines. Okay, primary amines. So then it becomes what? RNH2. RNH2. This is primary amine. If you replace two hydrogens with alkyl or aryl group, then we get secondary amine, that is R2NH. Okay, R2NH. And if you replace the three hydrogens, there are three hydrogens, so we can replace one more also. So then it becomes R3NS, that is tertiary amines. Okay, this is primary, this is secondary, and this is tertiary. And we know there are lone pairs too. Two electrons are the lone pair. So that can also be replaced. Okay, then it becomes what? R4N plus. Okay, this is quaternary ammonia. Okay, so these three are very much important: primary, secondary and tertiary. Then there are many methods for preparing this amines. So one important one is Gabriel Pthalimide synthesis. Let me write that. Gabriel Pthalimide synthesis. So from the name itself, let's see, this is Gabriel, that is the scientist who discovered this is Gabriel, and Pthalimide, the substrate used for the preparation of amine, that is phthalimide. Okay, so let's see how this synthesis method works out. So first of all, the substrate we told, that is phthalimide. So we need to draw first phthalimide. So in the previous chapters, maybe in carboxylic acid chapter, you maybe learned about phthalic acid. Do you remember the structure? Phthalic acid, that is, it has a benzene ring. See, it's a benzene ring, and it has two carboxyl groups through two carboxyl groups. Okay. So this is phthalic acid. So we have to prepare first phthalimide. So we are going to the structure of this phthalimide. So this is phthalic acid. We are adding 2 molecules of ammonia, 2 molecules of NH3. To NH3 if we add, what happens? We will get amines. See what happens when NH3 is added? This will be replaced. Okay, then we will get C double bond O NH2. Here also C double bond O NH2. This is a diamide, amide groups. Okay, now if we heat it further, what happens? Heating this, we get what? This ammonia is liberated. An ammonia group is liberated from here, and we get C double bond O. Here also C double bond O. Then what is remaining? NH3 is gone. Okay, what is remaining? An NH group. Okay, so that is here. NH. This is actually phthalimide. Okay, you got it. This is phthalimide. So let me rub this out. So this is phthalimide. Hope you got this. So the basic substrate we need is phthalimide. So let's start with that. C double bond O, C double bond O, then we have an NH group. So this is the basic substrate, and what we have to synthesize amines. So let's see what are the reagents, what are the conditions that we need. So first condition we need is a basic medium. We need to provide a basic medium. So what we take, first of all, in order to provide basic medium, we take KOH or we can take NaOH. Okay. So KOH or NaOH, the purpose of adding this is to provide a basic medium. Okay. Now what we need? We need to synthesize alkyl or aryl amine. So let's see what type of amine we are synthesizing from this. So next what we need is an alkyl halide group. Okay, alkyl halide. Okay. Now third one, we need to hydrolyze this. Okay. So hydrolysis. So these three steps are the essential ones. We need to provide a basic medium, then we need to give an alkyl halide, then we need to do hydrolysis. So let's see what is the product. After that I will say the mechanism. So first the product we get is RNH2. Okay, what is this? This is a primary amine. And what it is a primary alkyl amine. So we get primary alkyl amine. Then what? Then we get this is phthalimide. So we get a salt of phthalic acid. We get a salt of phthalic acid. This is O minus. If we are using KOH, we will get K plus. If we are using NaOH, we will get Na plus. So this is a salt. Okay, fine. So now let's see the mechanism. This is phthalimide, the substrate. Then what we have to give? We have to provide the basic medium. So let's start with KOH or NaOH we can give. So KOH, we are giving KOH. Why we are giving this basic medium? We are giving this basic medium in order to activate this. We have to activate this hydrogen. We have to remove it. So what we do is, this is OH minus. Okay, this acts as a base. So this OH minus abstracts this H plus. Okay, and what happens now? This N becomes minus. So what happens is, this is a phthalimide now becomes N minus. Here also C double bond O. Then we have OH and H. So it becomes H2O. So plus H2O is also there. Now here it is N minus. So this K plus can go with it. Minus and plus always goes together. Okay. So this is K plus. Now this is a compound that undergoes further reaction. Now the second condition, second thing that we added is RX, alkyl halide. Now let's add that. So next we added RX, alkyl halide. Okay, this alkyl halide, what undergoes here is a nucleophilic substitution. First of all, we saw only primary alkyl amines are formed. This is the reason why aromatic amines are not obtained by this method, because this nucleophilic substitution, we know aromatic nucleophilic substitution is very tedious, is it not? It does not undergo. If this is an ARX group, it's very difficult to undergo, or it does not undergo this nucleophilic reactions. If it is a benzyl chloride, nucleophilic substitution does not take place, is it not? So here we can use only alkyl halides. That's why we get only alkyl amines by this method. So that's very important. Okay, so this is, we know generally this is minus and this is plus, is it not? So what happens? This N minus goes with R and this X minus goes with K, potassium. Now the product that we get is, this is the phthalimide group. Then with this N minus, R plus goes, R plus. Now this X minus and K goes together and becomes Kx, that's gone. Now this is a substrate with us. So next what we have to do is, again we have this in basic medium. So we again add KOH. We need not add, there is KOH in the medium. So what happens with the KOH? What happens? This is OH minus and this is K plus. This OH, here it acted as a base to activate this H plus. Is there any H group here? No, there is no H. Is it not? There is no H. So now here it acts as a nucleophile. Here it was a base, here it is a nucleophile. So as nucleophile, what happens? This OH minus goes and attack this carbon and this becomes O minus. So this goes again back, then this bond shifts. Okay. See what is now? C double bond O, C double bond O, then an OH. This OH has gone here. So here is an OH. Here we have NR and this bond is broken. What happened is, here this nucleophile attacked carbon, an electrophilic center. So this carbon, then this bond shifted here, then again it underwent back bonding and this bond broken. Then what we got is, this bond is broken already. So C double bond O, NR. Okay, NR. Here nothing is there. This is the NR. Now C double bond O, OH. This is minus itself. Then what happened is, here proton transfer occurs. Proton transfer. This hydrogen goes to this negative one. Always this hydrogen is H plus, is it not? It has a tendency to go as H plus. So it goes to this nitrogen. And here it is COO minus. That is more stable than COOH. That what we have learned in the previous chapters. So here now it become, hope you can see, okay. So this is C double bond O, this hydrogen has gone here, so this is NHR. Then we have C double bond O, then O minus. Here O minus, we have K plus there, so here it becomes K plus, okay. So here K plus we have added, then we have OH minus also here, okay. Then this OH minus again acting as nucleophile, it can attack this carbon. Again this can go there, back bonding. Same step repeated. This bond gets broken. Now the final product is C double bond O, OH, C double bond O, O minus, K plus. Now this is RNH, okay, minus. Now again here proton transfer occurs, this H plus goes to this nitrogen and we get RNH2, RNH2. Now if this K plus is there, here also potassium salt is formed, okay, so here also K plus will come. So the final product that we get is primary alkyl amine. Okay, we cannot get aryl amines by this Gabriel Pthalimide synthesis, and we cannot synthesize secondary, tertiary, quaternium, ammonium with this method. Only primary amines are formed by Gabriel Pthalimide synthesis. Okay, it's very important. Thank you.